Alright, our first set of examples is the instructions say. The instructions say evaluate the function of each specified value of the independent variable and simplify. So f(x), remember x, this is fx, x is our independent variable. So this one's actually pretty simple. Don't not complicate it, even though people want to complicate stuff. We're going to f of 1. So 1. We're going to plug 1 into x, into all the x's into our equation. So f of 1 basically looks like this. 2, 1 minus 3. Because I plugged a 1 into the x, and that goes into this equation. So 2 times 1 is 2 minus 3. That equals -1. That's all you do. Okay? Next, it's f of -3. Plug in -3 into our x. So 2 times -3 is -6 minus 3, that makes it (-9). Again, simple, okay? Don't overcomplicate. Now, this is a complicated one where it gets a little bit complicated. It's fx minus 1. So wherever I have an x, I'm plugging this entire thing into that x. So it's going to look like this. Something like that, okay? Now, what I'm going to do, distribute. So it's going to be combine my terms. And those are your answers for something like that. Again, it can be pretty simple, but some students like to complicate it. And I'm going to do another example that's not on the board. I'll probably erase it and show you one similar to it. So now, moving on to 49. This is a piecewise function. Don't let it freak you out. A lot of students get freaked out from it. These right here, these are domain, or a set of values. So you're saying, this function, 2x plus 1, you only use this function when x is less than 0. And you only use 2x plus 2 when x is greater than or equal to 0. So you have to decide, look at the value, look at our set of restrictions, and evaluate. So when f equals -1, alright? -1, it's greater than or equal to 0, but it's less than 0, so I'm going to use this equation. So that means 2, -1, plus 1. Well, 2 times -1 is -2, plus 1, -1. That's your answer. F of 0. 0, this is x is less than or equal to 0, less than 0. This one's x are greater than or equal to 0. So when it equals 0, we use this equation. So that's going to be 2, 0 plus 2. That equals 2. Okay? And last one is f of 2. Goes in this one again because x is greater than, because 2 is greater than 0. So 2 plus 2 equals, 2 times 2 is 4, plus 2, 6. Piecewise functions are actually pretty simple. A lot of students freak out because it's something different or new. Now, let me write one up real quick because I think it might be helpful. And it's a common mistake I've seen with students. And it's only going to be part of the problem. So the number is 42. And it's h of t equals t squared minus 2. Minus 2t. So we have that, okay? Now, I'm not going to do A and B. I'm going to just do part C. Part C says at h of x plus 2. So where we see x plus 2, we plug it in to our t's. Okay, so that means we're going to get x plus 2 squared minus 2x plus 2. Again, wherever I see x plus 2, I plug that into my t's. Now, with this, we have to FOIL this. Okay, so this becomes this. I'm going to go ahead and distribute the negative 2x, so it becomes negative 2x plus or minus 4. When you FOIL, first, outer, and last, hopefully we should know that by the time we've been taking math for a while, right? So this should be x squared plus 2x plus another 2x plus 4 minus 2x minus 4. Combine like terms are only if they have the same exponent with the same variable. So there's no x squareds. Okay? We have a 2x and a minus 2x. We're going to go ahead and cancel that, but we still have an extra 2x plus 4 minus 4. They cancel. That would be our answer in this case. Why I wanted to show you that one. People, they don't FOIL this. They say that's just x squared plus 4. That's wrong. So make sure you FOIL that out. Make sure you distribute, and make sure everywhere you see it, you plug that in. So I'm going to erase this real quick, and then we'll start into some domain questions. All right. I'm not going to show domain right now. Sorry, I thought it was, but actually I'm showing 59 and 63 are finding when f of x equals 0. So that's our find all real values of x such that f of x equals 0. So that's what we're going to do right now for these two problems. And they vary, as you can see. So the first one though, but I don't have much room, so they're not too complicated. We want to know when f of x equals 0. So set 15 minus 3x equal to 0. Okay, move the 15 over, so negative 3x equals negative 15. Divide by negative 3, so x equals 5. That's all you do on that problem. It's similar to finding y-intercepts, or x, or sorry, not y, finding x-intercepts when you set at y equal to 0 and you just solve it, okay? This one, it's x squared minus 9. I'm going to show you there's two ways to solve this one. Again, we set that equal to 0. We can either move the 9 over, so x squared equals 9. Sorry, that got really small. X squared equals 9, and then square root. So x equals 3. Oh, it's a bad 3. But remember, we take the square root of something, it's plus or minus. So it's plus or minus. Here's another way of doing that one. So you get good at factoring. This is a perfect square. Factoring is going to come up soon, so we need to learn how to factor. We get that down, set both of those equal to 0. Because remember, this is equal to 0 at the end of the day. And we get x minus equals negative 3, and x equals 3. Same thing. Don't care which way you do it, they both get the same answer. Okay? That's finding when f of x equals 0. It comes up a lot. Now we have 67. 67 says find when f of x equals g of x. It's really not as complicated as it sounds. Go ahead and just set them equal to each other. And so that's just x squared equals x plus 2. Okay? When you have something like this, different powers, you cannot take the square root to try to get rid of it. That just makes it more complicated. What you want to do is move everything to one side. I'm going to move these over here. Or actually, you'll see it. So it's just 0 equals x squared minus x minus 2. From here, this is where we're going to have to factor. Now there's several ways that you can factor. There is the quadratic formula. I love the quadratic formula, and whenever we get there, I will teach you how to use that one in all its awesomeness. But for the most part here at the Aztec High School, we do teach the T-chart method for students who don't see it right away. Now, hopefully the idea is you've factored so long you see patterns on how to get this. But the T-chart method, I'm going to go over it real quick. You take this number right here, multiply by the number in front of x squared. There's nothing there, so it's just negative 2. That's the numbers that go here. So this is multiplication, this are plus, minus. Take this number, it's negative 1, it goes there. What are factors of 2? 1 and 2. Now the idea is we need to multiply them in such a way that we need to have the sign in such a way that when we multiply them, we get a negative 2. But when we add them, we also get a negative 1. So this one's pretty simple. That's just a negative 2 right there. We act like we're dividing by x, because that's what this is right here. And what I say is you rotate it so it looks like x plus 1, x minus 2. Remember, this is all still equal to 0. Like we did over here, we set each one equal to 0. Set those equal to 0. And so we get negative 1 and negative 2. Those are your answers. So this is true when you get those values. Okay? So that's how you do that. It's more math. We're getting to more math, more just stuff factoring. That's what's going to be the main course of section 1.4. So now I'm going to do domain in real quick. So again, erase it, prep, and we'll do domain. All right, let's do some implied domain. It's pretty simple, at least I think so. Hopefully by the time I go through this, it's going to be a little bit simple for you guys too. The first one, so what we're trying to do, we want to find the domain of the function. That is there, what I ask myself and what I try to get the students to do, is there an x value or a variable that I plug into the equation that I will not get a number out? That usually happens whenever I divide by 0 or I get imaginary numbers. Remember, real numbers, no imaginary. So this first one, I'm not divided by 0 and there's no square roots. This one's easy. Domain, all real numbers. So you just say x, all real numbers. The shorthand, and I also do this in class, the sign for real numbers. Freaks them out, but I still do it anyways. This one, moving on, it's 4 divided by t. Remember, I cannot divide by 0, so set t, the bottom equal to 0, so t equals 0. T cannot, though you'll say is t cannot be 0, but it can be all real numbers except for that. Okay? Now I mentioned earlier I was going to do an example of the square root. What we have is, what you do, we don't want imaginary numbers, so we don't want a negative value under there. So we say y minus 10 has to be greater than 0. Now it can equal 0, so we just set it up like that. Okay? Solve for y, so y is 10. Y has to be greater than or equal to 10. So we move the 10 over, boom, we're done. Now, let's combine them in 79. We have square root of x minus 1, all divided by x minus 4. So we have a couple stipulations here. I'm going to look at the bottom first. So set the bottom equal to 0. That means x cannot equal 4 for this to exist. Now let's go ahead and look at the top. We have x minus 1 is greater than or equal to 0. Go ahead and move the 1 over, so x. How do we write this one? X has to be greater than negative 1, or has to be greater than or equal to 1, but also x cannot equal 4, and that is our implied domain for that function. Implied domain is a very important concept for students to get. There's not many examples in 1.4, but it does come up later, and during then I'll go into heavy detail of how to find domain and kind of some ways to scratch it out or fix it. There's some more techniques that go with it. But for the purpose of 1.4, that's it. Okay, hope that helps. Alright, so this is section 1.4. It's functions. It's one of the it's one of the easier sections relatively compared to, like, say 1.3 was, and 1.2 can be a little bit challenging. It's more time consuming than anything. But 1.4, students seem to grasp really well. So 1.4 is functions. Now, what students don't grasp really well, and it doesn't matter how many years and how many times you try to teach it to them, they seem, domain and range seem to just escape, or they get used to it or something, but they seem to struggle with it at the beginning. Domain is all, and that's by definition, sorry, that's what that DF stands for. It's inputs, or I left it out, it's x values. It's what x can be. So that is, if x is undefined, then you have to say it cannot be this. And that's mostly when x is divided by 0. So you can't divide by 0. So domain, I'm going to go over some more with some more example, and that's going to be called implied domain. Range is our outputs, or y values. That's what we're used to seeing it. Of course, I'm going to change that real quick, what y values are. But domain and range, what inputs and outputs, what x can be, what y can be, okay? And we're going to do some examples where that comes into play. This is where I start changing stuff up. It's called functions, so we're going to start using function notation. And function notation, I personally believe this should be taught at the very beginning. Instead of using y, we should use function notation. And it's being taught more and more sooner in schools than so I'm liking that. But what we're going to have now, x is our inputs, that stays the same. Our outputs now is f of x, that's the same as y. So if you want to, f of x, this is the same thing as y. So whenever you see y, just put f of x there. Of course, the book's going to use like g of y, g of x, h of x, those are popular ones. So you can also see f of t, b of t, and stuff like that. That's the output. You see something like this, forms this kind of equation, f of x equals 1 minus x squared. So that's the equation now. Instead of y equals 1 minus x squared, it's f of x, okay? Now, moving along, we're going to find the values of f of x equals 0. A lot of students think this is confusing or something new. It's actually not. It means set f of x equal to 0 and solve for x. If you think back when 1.2, we were finding y-intercepts. That's what we did. Or no, when we were finding x-intercepts, that's what we did. We set y equal to 0, plugged in 0, and we just solved for x. For example, I'm going to use this example. 0 equals 1 minus x squared. We solve for if we were to solve for x, which I'll do some examples, again, how to do. Now, this is the part that gets kind of tricky. It's called implied domain. I have two examples here. F of x equals 1 over x squared minus 4. Rule of thumb, what you can do, and later on in chapters, I believe 2, it gets a little, throw a hiccup in there, but for chapter 1, the most part, find values that result in division by 0. So that is set the bottom equal to 0, x squared minus 4. Solve it for x, and that's where you get x plus or minus 2. If I plug a 2 in here, negative or positive, then the bottom equals 0. I cannot divide by 0, that's undefined. So this is like x could be any real number except for plus or minus 2. Another special case is f of x equals the square root of x. Real numbers, my students caught on very well, and students have caught on really well. Imaginary numbers, we learned them. You take the square root of a negative number, you get an imaginary number. For the part of real numbers, domain stays real. Do not include imaginary numbers. So the domain is set this, what's inside the square root, what's inside of it, greater than that number. So x is greater than or equal to 0. I'm going to do an example that's going to be like y minus 10 is inside the square root. So you set that greater than or equal to 0 and solve it. And I'm going to do an example of that. So those I think are the most important parts from 1.4. It is pretty simple. So let me go ahead and pause it, erase that, and we'll get going on examples.